Hi and welcome to Trig Graphs Day 1. Today we're going to learn how to graph the sine and cosine curves. First thing we're going to do is graph y equals sine x from negative 2 pi to 2 pi using 45-degree intervals. So graph first from 0 to 2 pi. We are going to need to convert from degrees to radians, and we will use radians on our x-axis. So every 45 degrees would be 0 degrees, 45 degrees, 90 degrees, 135, 180, 225, 270, 315, and 360. So that's counting by 45 degrees. In radians, 0 degrees is 0 radians. We know that 180 is pi. We know that 360 is, hang on. So 360 is 2 pi. And let's see here, 45 would be pi over 4. 90 is pi over 2. 270 was 3 pi over 2. And really the way to do this is to count by pi over 4s and just reduce your fractions. This would be 0 pi over 4, 1 pi over 4. This would be 2 pi over 4, which reduces to pi over 2. That would make this 3 pi over 4. 180 becomes 4 pi over 4, which reduces to pi. So 225 is 5 pi over 4. 270 becomes 6 pi over 4, which reduces to 3 pi over 2. And then we have 7 pi over 4. And then this would be 8 pi over 4, which reduces to 2 pi. So really all I did was count by pi over 4s. The sine of 0 is then 0. The sine of 90 we know is 1. Sine of 180 is 0. Sine of 270 is negative 1. Sine of 360 is back to 0. The other values I will have to use a calculator for, but to save us time, I will just tell you that's 0.7, this is 0.7, this is negative 0.7, and another negative 0.7. So when you graph a sine curve, it's a continuous curve. There are no breaks. So I have to go to the graph paper, which is the 3rd page into your packet. Get rid of these notes. When I graph, I have a point 0, 0. I'm going to make this 0.5, and this 1, and this negative 0.5, and this negative 1, just to make my graph look prettier. At pi over 4, which would be halfway between pi over 2 and 0, I had 0.7. And then at pi over 2, we had 1. At 3 pi over 4, we had 0.7 again. At pi, we had 0. At 5 pi over 4, we had negative 0.7. At 3 pi over 2, we had negative 1. At 7 pi over 4, we had negative 0.7. And at 2 pi, we had 0. So it's one smooth continuous curve, and we connect our points. Okay, notice the patterns, and then use this pattern of continuous curve to graph y equals sine x from negative 2 pi to 0. Well, if you notice, it's continuous. It's up and it goes down, and I'm going to keep going backwards here, so I will be at negative 0.7. And at negative pi over 2, I'd be at negative 1. and then negative 0.7, and then at negative pi I'll be at 0. We've got 0.7, negative 3 pi over 2 we have 1, 0.7, and negative pi we have 0. So my curve is going to come right back through. And we label it with y equals sin x. Now, that is my curve. What I want you to do is go back here to our first page. And we're on number 4. Show how this how it relates to the unit circle. Well, here's my unit circle. And 0 and 360. And this is 90, 180, 270. This is the point 1, 0, the point 0, 1, the point negative 1, 0, and the point 0, negative 1. Alright, if you look back up here at the chart, right about here, okay, right at 180, that splits my axes in half. At 90, splits my axes in quarters. At 270, splits my axes again. If I am in quadrants 1 or 2, because from 0 to 180 is quadrants 1 and 2, all my x values are positive. If I'm in quadrants 3 and 4, all my y values are positive. If I'm in quadrants 3 or 4, all my y values are negative. So sine is positive in 1 and 2, and it's negative in 3 and 4. Okay, so let's go back to our graph. And if we look at our graph here, 0 to pi is, this is quadrant 1, pi over 2 to pi is quadrant 2, pi to 3 pi over 2 is quadrant 3, and 3 pi over 2 to 2 pi is quadrant 4. I've kind of just unrolled my unit circle onto my axes. Notice this graph reflects through the origin. Alright, it goes right through and comes back out. And like I said, here are my quadrants, quadrants 1, 2, 3, and 4. Sine is positive in quadrants 1 and 2, so that means it's above the x-axis. Sine is negative in quadrants 3 and 4, so it's below the x-axis. Alright, it asks us for our domain. Well, our domain is our x values. We have no restrictions. So our domain is x such that we have all real numbers. Our ranges are y values. If you go back and you look at your graph, there's nothing greater than 1 or less than negative 1. So that means my range is y such that we have everything is between negative 1 and 1. But our intervals of increase and decrease, well, our intervals are increasing. We look at our graph, our intervals are increasing in quadrant 1 and in quadrant 4. And that's just on the right side, but it wants to know for the whole thing. So we are increasing negative 2 pi to negative 3 pi over 2. And then again from negative pi over 2 to pi over 2. And again from 3 pi over 2 to 2 pi. That's when my graph is increasing. My graph is decreasing everywhere it's not increasing. So negative 3 pi over 2 to negative pi over 2. And again from pi over 2 to 3 pi over 2. Alright, we're going to do the same thing except this time with our cosine curve. So in degrees we have 0, 45, 90, 135, 180, 225, 270, 315, and 360. In radians, this is 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Alright, cosine of 0 is 1. The cosine of 90 is 0. The cosine of 180 is negative 1. Cosine of 270 is 0. Cosine of 360 is 1. All I'm doing is looking at my x values on my unit circle. And then here this would be 0.7, negative 0.7, negative 0.7, and 0.7. Again, no, it's a continuous curve, there's no breaks. So let's go to our graph. Alright. So for cosine, starts up here, we'll do this 0.5, here's 1, negative 0.5, negative 1. So we start at 1, 0, 1, and then will be 0.7, pi over 2, it's 0. At 3 pi over 4, it's 0.7. For pi, it's negative 1, 0.7. 3 pi over 2 is 0, 0.7, and then 1. So connect my curve, my points, make my curve. And then this pattern is again going to continue. And now we're going to graph the other half. So we have 0.7, 0, negative 0.7, negative 1, negative 0.7, 0, 0.7, and 1. So this is y equals cosine x. Notice this graph reflects over the y-axis, whereas my sine graph reflects through the origin. Going back, if we did up above, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is in quadrant 4, and we know that all students take calculus, so quadrants 1 and 4 is where my graph is positive, quadrants 2 and 3 is where it's negative. Show how this relates to the unit circle. Well, again, we just did our unit circle on the other page. So now we need to draw it again, but cosine is positive in quadrants 1 and 4, and cosine is negative in quadrants 2 and 3, and according to our graph, that happens as well. Oh, I think I forgot to do something back here. Find all x-intercepts. Did I forget to do that? Oh, yikes. I forgot part A. Find all x-intercepts. Sorry about that. That's everywhere it crosses the x-axis. And that would be at 0, pi over, or pi, and then 2 pi. My bad. Sorry. For cosine, my x-intercepts are, looking back at my graph, negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. Again, going back, forgot to do the negative ones. That would be negative pi and negative 2 pi. My domain, again, I have no restrictions, so x such that x is all real numbers. My range for y, it's somewhere between negative 1 and, okay, so let me do less than or equals to here. Less than, or here we go, less than or equal to y less than or equal to 1. Intervals of increasing or decreasing. Well, my graph is increasing from negative pi to 0 and pi to 2 pi. And this is increasing. And it's decreasing from negative 2 pi to negative pi, and again from 0 to pi. And I get that by looking at the graph here, my cosine graph. It's increasing from negative pi over 2 to 0, and then again from pi over 2 to 2 pi. It's decreasing from negative 2 pi to negative pi, and again from 0 to pi. I just got that by looking at the graph. Alright, so that's graphing a sine curve and a cosine curve in a nutshell. Good luck.